correctly. However, when using it to extinguish a fire, there are several factors that should be taken into account to ensure maximum effectiveness and prevent unnecessary damage to the surrounding area. Among the things you should keep in mind are correct posture, use of correct equipment, avoiding unnecessary water usage, electrical systems, frost, liquid fires and extinguishing methods, ship stability. Though it takes a very large amount of water to endanger a ship's stability, this is a potential hazard that should be kept in mind. It is not uncommon that after many hours or even days of firefighting aboard a ship and finally getting it towed to a dock, the ship will suddenly capsize or sink. The effects of water being pumped on board a ship will vary and will depend upon a number of factors, including the design of the ship. The excess weight of water being pumped on board can raise the ship's center of gravity if it accumulates on the upper decks. It can also have the reverse effect. In many cases, large amounts of water on board a ship can result in seriously reduced stability due to the movement of this water back and forth in the structure. This can cause the structure to become more unbalanced, and the ship's ability to upright itself from a tilt will also be reduced. Whenever you are pumping water on board during a firefighting operation, you should keep in mind where the water is going and consider removal or relocation of that water. There are things you can do to limit and handle water on board so that you can avoid capsizing or sinking the ship. Click on the phrases below for more information. Using fog instead of straight steam helps to limit the amount of water that collects on board. This is also a safer option when you consider the nature of fires on ships. A ship is constructed of steel, and in many areas, doors and ventilation ducts are sealed off during a fire to create a boundary. Though this creates a barrier to the fire, there is the risk that if the fire has been burning for some time, the floors, walls and ceilings of these areas will have become red hot. Most hoses produce 150 gallons, or 568 litres, of water per minute. When water turns to steam, it takes up 1,700 times as much space as it did in its liquid state. This means that when the firefighters spray water directly onto these hot metal surfaces, there is a sudden blast of pressure and heat resulting from the water turning into steam. This could seriously injure or even kill the firefighters if they are in a confined area. This is why fog nozzles are considered the better option when fighting fires on board ships. The use of fixed firefighting systems, such as powder, foam, CO2 or halon, will also help reduce the need for water in onboard firefighting operations. High-expansion foam contains only a small fraction of water and creates a blanket that helps cool and suffocate the fire. Since water has a tendency to collect on the upper deck, if circumstances allow it, the water should be pumped overboard. However, in some cases this may not be possible, in which case you will want to move it to a part of the ship where it will be less destabilizing, such as lower decks. One way of doing this without pumps is to break apart toilets in a flooded upper deck area, so that the water can run down to the sanitary tanks. Experience has shown that during major catastrophes, communication can cause many problems. Reliable communication depends upon proper organization and coordination. Communication failures can lead to many different problems, such as misunderstandings, frustrations, waste of valuable time, and may even endanger lives. Among the lessons learned from previous experiences are: smoke divers should be equipped with their own hands-free UHF system. A strict level of discipline in communications between the master, fire chief, and smoke divers must be maintained. PA systems and internal UHF systems should be double redundant and independent of each other, so that full communication is maintained between both crew members and passengers during and after the fire, no matter which rooms have been flooded. All systems should be connected to a UPS. The local rescue services should be able to contact the ship's master at all times. The way in which firefighting is organized on board a ship will greatly affect its performance. The organizational overview should give some insight into how to best utilize a crew in a given situation. In order for the organization to function correctly, it is important that personnel have the right skills and are self-disciplined. Crew members must be trained and drilled in their duties, so that they are confident in their ability to carry out those duties. In any incident offshore, the decision to mobilize lies with the local fire chief or master. Offshore response teams to be mobilized will assemble at a predetermined embarkation point, where they will then be transported to the vessel. Upon arrival, the head officer of these teams will assist in the management and delegation of duties in the firefighting operation, and it is important that the shipmaster and the vessel's fire teams cooperate with the head fire officer. The fire teams must be informed of all of the details of the situation and what potential hazards may exist. Usually, arrangement plans and other diagrams of the ship will need to be examined to understand the situation better and determine the best method of attack. It is also important to inform the head officer if there are any inaccuracies in these documents. In order to fight the fire effectively, the ship should be moved to a local port if possible, where equipment and supplies are readily available. In addition to the immediate heat and smoke of a fire, there are numerous other dangers that must be taken into account during any firefighting operation. Excess water heated by the deck can cause scalding burns. Firefighters may experience heat exhaustion and dehydration during an operation, which can incapacitate them. Click on the buttons for information on these hazards. Knowing your cargo is essential for your own and others' survival during firefighting operations. When a material burns, a chemical process takes place that can release flammable or explosive gases as well as toxic fumes. You must also understand how your extinguishing medium can react with the cargo and other elements in the environment. It would, for example, not be advisable to hose down an area with water in which magnesium was present, since the resulting hydrogen gas would cause an explosion. Dry distillation is the process whereby organic materials are heated and release both liquids and gases. Both these liquids and gases are combustible and provide extra fuel for any fire, and can cause backdraft explosions in enclosed areas where gases could become superheated. This is a common problem on shipboard fires, since many of the materials on board can generate large amounts of these flammable substances. Today's cargo carriers transport many types of dangerous goods. Some substances are a danger to health, while others are a danger to the environment. For some substances, there may be a danger of certain chemical reactions, whereas others may produce toxic gases when ignited. In the event of a fire or leakage involving dangerous goods, there are several factors that must be taken into consideration, such as what is burning or leaking, what kind of chemical reactions can take place, what kind of flame or heat intensity can be expected, what kind of toxic properties do the chemicals have, what are the properties of their byproducts, what kind of extinguishing techniques and mediums are the most effective. This information is enclosed in the Dangerous Goods data card. The card also shows the action to be taken in the event of an accident, and steps to be taken in the event of a spillage or fire, with reference as well to first aid treatment. Factors that determine how a fire involving dangerous goods evolves include physical traits such as steam pressure and solubility, wind direction, chemical properties, flame velocity, heat radiation and spread rate, production of fire gases. Flammable materials such as paints, thinner, etc. must be stored at a specially designated area designed for their storage. The ceilings and linings of these rooms must be constructed with non-combustible material, and the area must be equipped with automatic sprinklers, fire detection and a fire alarm system of an approved type that complies with the relevant requirements of SOLAS. As with any emergency, there is the possibility that there will be injuries caused by the situation, and you will need to be prepared for this inevitability in advance in order to properly and effectively deal with the problem when that time comes. All medical equipment must be in good order, and both the medical officer and crew members assigned to medical teams must be familiar with the equipment's use, as well as proper first aid procedures. Click on the buttons below for more information on the subject. Medical responsibilities will vary from ship to ship. While large passenger ships will usually have their own medical officer, the responsibility for medical care normally falls upon the chief officer on most cargo ships. Great care should be taken when handling injured persons. Moving a person with broken bones or an injured spine incorrectly can result in further injuries. Splints or other supports should be set on potentially broken bones before a patient is moved. However, if a life-threatening danger exists, such as a fire or a collapsing structure, it is more important to move the patient as quickly as possible to a safe area. Upon discovering an injured person, you should always check the site for any hazards that could result in injury to yourself, and alert the appropriate personnel. Summon trained medical personnel immediately. If the victim has been rendered unconscious, you will have to initiate the first aid ABC procedure. This stands for airway, breathing and circulation. For information on this and other medical procedures, refer to the Medical First Aid and Medical Care CBT modules.